Good morning, speaker of the day, Dr. Sudhir Misra, who has taken off time from his schedule to join us. And good morning to all the construction professionals who have logged in. And we welcome all of you to this 55th webinar. And we have been conducting a lot of webinars on various topics of cement, concrete, plumbing, sustainability, and various panel discussions were there. I am sure that those would have been very useful to all the construction professionals. Just a couple of announcements. We have a series of webinars from June 22nd to 26th, basically focusing on analysis and design of liquid retaining structures. And this is being conducted in collaboration with ACC Goa Center. Because when we were collaborating, when we were interacting with many engineers, they had a lot of doubts and on liquid retaining structures. Is it different from other normal structures? So what needs to be done? So for that, what we have done is that we have got a couple of experts who would be speaking on 22nd and 23rd June. We have Mr. L.K. Jain, who would also be speaking about IS 3370, part 1 and part 2, and the philosophy behind it. So what we are doing is that we would be circulating those codes also, so that one can read through it and then prepare questions and come during the webinar, so that you can post the questions to the speakers on that day. So those webinar links and the links to the reading materials, we would be sending it, and we would also be posting it on our Facebook post. And if you need also, we would also be giving you the contact number of some of our technical services manager whom you can get in touch with. So we will be posting shortly on our Facebook on Ramco Cements Limited regarding this webinars which are going to come up during the next week. So just a couple of this thing, although all of you know about Ramco Cements Limited is the flagship company of the Ramco Group. And we have 12 brands of cement ranging from ordinary Portland cement, PPC, PSC, SRC, RHPC, all based on the concrete requirements of the customers. So that is why we have all these varieties of cement. The total capacity is 16.5 million tons per annum as of now, and it is expected to reach 20 million tons per annum because of the various expansion that is happening. We have one new greenfield plant coming up at Kurnool in Andhra Pradesh, and we also have our Orissa grinding unit which is coming up. And we are also into ready-mix concrete. We have a ready-mix concrete unit at Chennai, and we are also manufacturing dry mortar products. And we are one of the largest wind farms in the country we have got. And we have got a research center, the Ramco Research Development Center at Chennai, which does a lot of work on cement and concrete and various other raw materials. So this is just an overview of the various types of cement that we are manufacturing. Ordinary Portland cement as per IS 269. We have this infra cement which is being mentioned here specifically for concrete with high slump retention. We have the rapid hardening Portland cement for precast works, the Ramco Superfast cement. We have the Portland Pozzolana cement which is being sold in huge quantities across the country. Within Portland Pozzolana cement we have the Ramco Super Grade, Ramco Super Crete, Ramco Super Fine, Karthik Super Plus. Now Ramco Super Crete is a cement which can give you high rate of gain of strength and a low heat of hydration. So that is what premium cement for concreting. And we have got Portland slag cement, Ramco Super Steel and Ramco Samudra. And we have got the sulfate resisting Portland cement, Ramco Super Coast. One caution that one needs to exercise is that whenever you have sulfates in soil, please also examine whether there are chlorides also along with sulfates, because SRC cement is weak in resisting chloride. So if you have both sulfates and chloride, it is always better to go in for a blended cement so that it can resist the attack of external agents. And we have a number of project customers who have been associated with us, the Lasnan Tube Row Limited, ITD Cementation, and many projects in the eastern part of the country as well as southern part of the country. The idea is that based on the interaction with these project customers, we have been able to understand the various challenges that they face in the concrete at when they use it for various kinds of structures, whether it be bridges, whether it be under different exposure conditions. It can be either near coastal areas, it may be underground, so many different kind of challenges that a civil engineer faces. And we have the Research and Development Center, which in fact brings the site practices with the theoretical theoretical framework, and then we try to give out a viewpoint from our side to the customers so that they can try it at their site, at their field. So let me not take much of the time. Today we have a speaker who would be speaking on a critical aspect of our field, in fact the continuing education, which is very important. Dr. Sudhir Misra, who has joined us from who is a professor at IIT Kanpur, and he is also the chairman for the ICI-Lucknow Center. He has been teaching at the Department of Civil Engineering, IIT Kanpur for more than 25 years. His research interests include concrete materials and engineering, including special concrete, such as high strength and self-compacting concrete, deterioration, non-destructive testing and evaluation, and repair and rehabilitation for concrete structures. A graduate from IIT Kanpur in 1981, he completed his PhD from the University of Tokyo in 1989. He has worked for about 10 years in Engineers India Limited, New Delhi, Hindustan Construction Company, Mumbai, and Kajima Corporation, Tokyo, Japan. Dr. Mishra has spearheaded creation of a graduate program in infrastructure engineering and management in the Civil Engineering Department, IIT Kanpur, and has published and presented more than 80 papers in journals of repute and national and international conferences. So that's the speaker for the day, who would be sharing with us some of his valuable insights based on his experiences in academics, in construction companies, in consultancy. So that's a very rare combination that we have. And we welcome you, sir, to interact with all the professionals. And we are sure that there will be a lot of insights, lot of takeaways from today's talk. Over to you, Mishra Saab.
Thank you, and all of you in Ramco for giving me this opportunity. I hope you can see my screen. It's a blank screen right now. I mean, it's just a blank slide that I put there. So thank you for all the nice words, kind words. And it's a pleasure to be here with you this morning from here. I understand. I do not know right now whether any of you are joining from outside India as well. If you're joining from outside India, very warm welcome to you on behalf of all of us here in India. And given the fact that I was told that the audience for today would be civil engineers or maybe non-civil engineers from different who are related in or working different construction related areas, I thought I'll talk to you about something which is relevant to all of us. I don't promise to answer too many questions. I hope to leave you with a lot of questions, which if you are able to come up with answers, I think that will be the takeaway from here. If you are able to think about some answers and kind of move forward, my job, I think, would be done. So what I'm looking at today, ladies and gentlemen, is the 4 and 40 challenge, the importance of continuing education. Now, this 4 and 40 challenge, in fact, the organizers were kind of confused as to what I wanted to know. And in fact, I was also equally confused as to what I will talk about. We'll go along and we'll have some fun trying to understand what it is. Okay, so what is this 4 and 40 challenge? Very often, now I want to do a trick here, which is this. Right. Now, very often when I talk to practicing engineers, I hear laments about engineering curriculum in colleges. What these professionals tell us in engineering colleges is that the education that we impart to our graduates here, especially undergraduate education, I'm not talking about postgraduate education, okay? So when we talk of BTech kind of education, then these people don't know anything. And I have to take it with a pinch of salt because I half know that, yes, they do indeed do not know anything. Then, oh, what happened? I cannot change my slide. Why is it stuck?
It is stuck, sir?
It is stuck, yes. So,
okay. Suraj, can you help us? I think what you can do is that you can just again start off, sir, if it is stuck. If it is not proceeding.
I think I'll go back and stop screen sharing and start again.
Stop sharing and then again share it, sir. Yes.
I think that's what I'll do. I'll stop sharing.
Yes. And then again start sharing, yeah. There was, it got stuck, Suraj.
Yeah, sir.
No, it's all right. So that's right. So now coming back to this, they say that these engineering graduates don't know anything. And then they also give us advice. That is, they say that, well, you should include this in your curriculum. You should include that in your curriculum. They should know more about superplasticizers. They should know more about finite element methods, and so on and so forth. Again, I have to keep listening to it. So I thought, okay, fine. Now, my proposition to you, ladies and gentlemen, for today is that I'll put it very bluntly. If you study in a college for 4 years and get a degree in civil engineering, and what is taught to you, hope that what is taught to you should hold you in good stead and suffice for a 40-year career. Now, see, we joined our careers, let's say around 22, 23, 24, something of that order. And then let's say we work till about 65, 60, 65, whatever it is. So we are looking at a 40-year professional career. Now, if we think that that 4 year of education is what I'm going to rely upon and build my 40-year career on that, this will simply not happen. It cannot happen, which means that we have to keep studying. And now my question, you see, I'll leave you with a lot of assignments. See, a problem I'm in the habit of giving questions and asking you to think about it. I would request you to think, how much time do you, all of you, spend studying over a period of years? Over the period of years, it's not that I study 1 year, 1 hour every day and so on. No, that's not the issue. Do you spend 5-man days, 7-man days, 10-man days in a year really seriously studying? Okay, so I think you cannot rely on this 4-year education to hold you in good stead for the 40-year career. That is the part of 4 and 40 challenge. Now, let me, as far as this talk is concerned, what I try to do is explain to you the exercise of curriculum design. What are the constraints that operate on our side when we do a curriculum design? The thought process, the constraints, and then I will try to highlight the importance of developing appropriate modules for continuing education. Now, continuing education means education which you take when you are working somewhere. You're working for a cement company, you could be working for a construction company, a design company, a consultant, a government organization, whatever it is. And how to leverage technology for this education. So these are some of the points that I thought I'll touch upon. Coming to the first part of the discussion, which is the college education. Now, if you look at it as a process, what really happens is that there is some annotation tool here I can figure out somewhere. There is an annotation somewhere. Here it is. If I do this and I do this, then I am ready to do this. Somewhere I should be able to write something, isn't it? How do I write something on this?
Pointer, is it the board?
There is a something on the left hand side has come up. Let me see.
Yeah.
Or I'll probably just stick to.
Okay. On the screen itself, you may be able to write. But it is on.
I can move my. There is Cisco even.
You'll have to stop the slideshow and then write it on the slide, sir. Probably.
Yeah, I think that's right. Start annotating. Okay.
Yeah.
I can do something. Okay. Let me just go back to this. It's all right. Why is it saying? Why is it not listening to my OK here? Which says that Cisco Web, you are now the host of the event. I understand that. So why don't I OK it? Anyway, so let's go back to our work. See, we take high school graduates from different universities, from different boards. We create a process here, what is education, and we create the output, which is graduates. So we are looking at purely as an input-output model. We take raw material, we process it, and we create graduates. Now, in that sense, again, it has got stuck.
Is it?
Yeah, I think there is a problem. I'll stop annotating. Let's see if it works. No, it's not working. Okay, now I think it might work. No, it refuses to work. So I'll have to do. Oh, I got it right. So solar moves. Okay. Now, once it comes to this education process, what do we do? For civil engineering education, our evolution has been happening over hundreds of years. Computer science is just about what? I don't know. The first degrees in computer science were given around 1985 or 86 in this country. So a BTech in computer science is just about 35, 40 years old. BTech in civil engineering would be hundreds of years old. I mean, Roorkee probably had the oldest college which had a civil engineering degree. So in civil engineering, we are very vast in the area that we have to cover. And all this knowledge with the widest scope has to be fitted into this education part before we graduate our students. Apart from this, engineering and particularly civil engineering is practice oriented. Now, there is a lot of theory that goes into engineering, but there is a lot of practice. Practice means, all of you, I would guess, drive cars. The theory of driving a car is very simple. You put the engine, you start the key, and then you press the clutch, and something will happen, and then you release the accelerator, and I can keep telling you all this. I can tell you the mechanical engineering part of it, that when you engage the clutch, this happens, and when you press the accelerator, this happens, and so on and so forth. But when it comes to the practice of driving the car, unless you sit in the car and do it and learn the hard way, that several times you'll press the accelerator too much, several times you'll delay your release of the clutch, sometimes you'll not give the indicator and turn left. So you have to learn those things till such time as they become a part of your habit. So engineering, and particularly civil engineering, has this major practice orientation, which is simply not possible to cover as far as theory classes is concerned in the educational institute. Now let's look at a slightly different dimension. From our point of view, we produce civil engineering graduates. Now, where do they go? They may start working for designers, consultants, contractors. Again, there is a spelling mistake. It was, I thought I should have corrected it. I'm apologizing for that. There is an R somewhere here which I have missed. My apologies. Bad quality. So they can be working anywhere. Then there are government organizations. There are teachers like me. We all graduated from somewhere, right? I graduated from Iit Kanpur, and I'm now trying to teach people. A lot of you would have graduated from different colleges and working somewhere here. Then, from a specialization point of view, we could be working with environmental engineering, structural engineering, transportation, remote sensing. The whole works. I mean, these lists are by no means complete. I'm not even counting our graduates working in places like software, finance, banking, and so on and so forth. Now, if you look at it from our process perspective, if this is where our graduates are going to be going, this is where our products is going to be used, even if I leave this part out, what all do we teach in the 4 years that I have? So that in this class, which I have, let's say 100 people, 120 people, 10 people end up here, 10 people do this, another 15 do this, 15 people go here. What all kind of tools and tackles do we impart to them so that they become useful to the society? On top of that, the profession expects graduates to be the plug and play engineers. That is, they should be ready to meet very diverse requirements in their own profession. I mean, you go and work for a cement company, you go to a cement plant, you are expected to know how cement works or how the cement plant works. You should know the entire process and so on and so forth. Therefore, given this diversity in our requirements, whether it's you're posted to a site or a design office or a cement or a ready-mix concrete plant or wherever you are, you go to a government job, you are told to estimate quantities, you are going and operate a tender, whatever you want to do. All that forces us in the curriculum to have structural engineering, environmental engineering, surveying, transportation, irrigation, geotechnical, the whole works, everything is crammed into our curriculum. On top of that, in the last, whatever, 20, more than about, I would say about 30, 40 years in India, maybe 50, 60 years in the rest of the world, there's been a lot of mechanization in the construction process. There have been a lot of advances in construction methods and materials. There have been changes in the contracting systems. This has added a completely different dimension to the civil engineering profession. Now, once you say that people have now come up with this sustainable construction, they've come up with this project economics and finance, equipment and construction methods, quality and safety in the these are the advice. This is the advice that we get. I don't know how many of you understand Hindi. So long as you're in India, I can probably take a guess that you probably understand Hindi. But if you're outside, I must apologize for you just saying one sentence. People tell me, "Ye to padhana chahiye." I can. That is, this must be taught. I mean, I can understand it must be taught, but please tell me, should I sacrifice structural engineering to teach quality and safety? I just can't do that, right? So it's my problem is what all can we teach? We have only 4 years. Now coming to this slightly, these are all different dimensions to our education. You go back, I'm taking you back to the 4 years that you spent in your college and tried to study whatever you tried to study. And given the practice orientation, we have this whole story of codes. I mean, if you're working with structural engineering, that's where my I'm a little more familiar with the situation there, so I can talk of IS 456. I can talk of IS. The steel code is 800. Then I have all these cement codes which are 269. Then aggregate is 383, and so on. So that is the practice orientation. The codes are a matter of practice. Codes tell you what is practice. Codes are not educational instruments. The education has to be, in theory, the principles. But when you talk of the practice orientation, the codes come in. And regardless of what is given in the theory, finally it boils down to what is the provision in IS 456 for code testing, acceptance criteria, 1343. How do you do piece testing? You don't do piece testing, whatever you want to do. So those codes, some people believe that yes, they should be a part of our education system. Now the problem with teaching, I don't deny it. Even at IIT Kanpur we do it. See, when I say all these things, it doesn't mean that IIT Kanpur doesn't do it. IIT Kanpur is exactly in the same boat as anybody else, any other engineering college. So when we try to talk of design of facilities, whether it's steel or concrete structures, it was mentioned that there's a webinar going to be there on, let's say, liquid retaining structures and what kind of cement to use, what kind of cement not to use, and so on. Sewage treatment plant design. So now this design is a different discussion. Please also remember that the thought process and design is very different. And all codes, absolutely all codes, are time dependent. So all of you, depending on how long you've been in the profession, you would have, I don't think anybody, but I'll be surprised if people are there in the audience here who have, let's say, studied IS 456 of 1978. A lot of you would have probably studied the 2000 variety, but the 78 variety was there. And some of you will probably have at least heard of the 78. So now, once we talk of, just give me a minute. Once we talk of this time dependence of codes, then what is the point? IS 800, some of you have studied the previous version of IS 800. Now it's a completely different code. So blame us. So from an education point of view, if we focus our education on codes, then codes are time dependent. They will change while you are practicing engineering. Therefore, one thought process can be that let us not talk of codes. Let us talk of the principle of design. The principle of design means you have a beam, you apply load, there is a deflection. Some concept that yes, the maximum deflection should be limited. Now, how that maximum deflection, how the deflection is to be calculated, half of it is science, half of it is engineering. That kind of a discussion is what is needed in the classrooms. And then if you start working in a cement plant or a cement industry, deflections in beams are hardly a great thing for you. I mean, you are interested, you want to know something else, right? So that is where we are as far as education is concerned. So now going back to the old story that with an education of 4 years, we want to work for 40 years. It's a little too much to ask. And that is really the 4 in 40 chapters kind of thing. So I think I've spent enough time trying to figure out or put this part of it in perspective. Okay, now let me tell you, go over this, a slightly different dimension to our practice part of life. What you see here is a medical college and you see a hospital. You see the relationship between these two? So do you know the relationship between these two? Medical college, where is the mouse here? The medical college is the place where medical education happens. People are being taught to be doctors. And this is their karma bhumi. This is where they are going to be working. So for any medical college worth its salt, there is a functional hospital attached to it. The students need to attend patients under a guiding doctor. See, please take it with a pinch of salt. I'm not saying that if you go to a hospital, there'll be students who will be attending, I'm sure there are protocols by which there are teachers who tell students, but then the practice part of it, see, medicine also is a highly, highly practice-oriented profession. You can teach any amount of physiology, anatomy, pharmacology, whatever else these people are supposed to learn. But finally, it boils down to a doctor's ability to look at you, to understand the symptoms and make a diagnosis and move to the treatment. So there is that element of judgment which is involved. So the second part of it is that the teachers are practicing doctors. So the guys who are teaching here, they have two hats. They are teachers who teach medical college students. And then when they come here, they remove their teaching hat, they start practicing medicine. They teach the students the practice of medicine, practice of surgery, practice of everything. And medicine, by the way, is equally complicated. I mean, they have hundreds of specializations, super specializations, much like engineering. I mean, we have mechanical, civil has earthquake. I mean, civil has structural, and then within structural there's earthquake. So we have our own parallels that we can talk about. Now you think of the engineering education that you had. Whatever this engineering college is, this to me is the only karma bhumi for a civil engineer. Unless you are able to build or be part of the building process. I mean, you don't have, everybody doesn't have to be a contractor, because that's what the normal concept of building would be, that the contractor builds, but the contractor builds what the designer designs, and so on. So unless you are part of this building process, you're not a civil engineer worth its salt. Then you are a paper driver. You have never driven a car. You know how to drive a car, but you've never driven a car. So if unless you do this here, this education remains incomplete. And since we do not have this site as part of this college, it is almost a given. You are forced to have a situation where your education here will be incomplete. You can imagine if this hospital, if I take out from the medical college, and then we have doctors coming out of the medical college, and then you take them to the hospital. Just imagine what the situation will be. Okay, so that is where our education system is. We try to keep reviewing our education system. We do that. We try to evolve, change the things, bring in new ideas, new knowledge. But then the fact is that in order to accommodate the new knowledge, the old knowledge or the old courses have to go out. Except that we simply don't have the space to remove it. I mean, do you think we can remove a course like fluid mechanics? I mean, we cannot do that. Environmental engineering, we cannot do that. But if we cannot remove the basic courses, but somebody wants us to teach environmental impact assessment, it is an impossible task for us. When we design the curriculum, our thought process basically is that we should first create an educated graduate, then that person should be an engineer, and that should be an engineer of a certain discipline. So what it means is that there are some common courses that everybody is expected to do: physics, chemistry, mathematics, basic fluid mechanics, maybe some thermodynamics. So each college, each university has its own set of these courses. And I'm going to take the example from IIT Kanpur. The further examples are from our curriculum design. So basically, there is no concept of specialization in the undergraduate scheme of things, except for a few courses which are available under electives. Okay. So now, what are the constraints under which we work and when we design this curriculum? The first thing is that we are forced to work with an 8-semester program. An 8-semester program that is told to us, and at the government. And you see, it's not IIT Kanpur decides it. IIT Kanpur suppose decides that we are going to create a 10-semester program because we want to teach more. Nobody is going to come to us because giving us a degree in 8 days. I mean, 8 semesters. Why are you taking it 10 semesters? So we have these kind of issues that we have. Certain things are given to us. It's an 8-semester program, and we have to define systems like credits, hours, contact hours, courses, and so on for effective delivery. That we should be able to effectively teach them whatever it is, keeping in mind the absorption and understanding of the students. It's not enough for us to just bombard them with information and tell them that we have taught you and that's where the matter ends. So teaching, if it's a one-way process, like I'm talking to you, if this was teaching, That's very nice. I mean, but whether you understand or you don't understand, I don't care. I mean, that's not the way we would like to look at education. Each semester out of these 8 semesters is supposed to have 14 weeks, by and large. Then there can be not more than a certain number of courses in each semester. Each course cannot have more than 3 lectures in a week, labs, tutorials, and so on. Each lecture cannot have more than 50 minutes. So once you go back from this, do the arithmetic, each lecture is 50 minutes, 3 lectures to a course, so many courses in a semester, and 8 semesters. It more or less limits the amount of material that can be delivered over a 4-year period. We cannot deliver the whole bunch of knowledge to the students. We cannot flood them. We don't want to flood them, and there are constraints, inbuilt constraints, which force us or kind of make sure that we do not do it. Now, if we look at the Iit Kanpur syllabus in curriculum, we are trying to do a revision, so don't bother about these numbers so much. They may be off by another course here or course there, but the principle will remain the same, that we have this institute core, which is our compulsory system, which is sciences, engineering sciences, mechanics of solids, some electrical circuits and electronics, data structure, statistics, fluid mechanics, 5 courses here, a couple of courses here, and all this, if you see, technical arts like drawing and workshops, humanities and social sciences, economics, sociology, and so on is 7. So we have about 23 courses in our institute core. As far as departments are concerned, the department courses, and that's where the meat of our civil engineering education happens. Here it's like for people in India would understand when I say that this is like a common minimum program. It's a multi-party government. It's a coalition government. So with structural engineering, if you think of it as a political party, they probably have more clout than others. So they have somehow managed to garner 3 courses. Geotech is a little less powerful than 2. So some of these courses are there. This is the total number of courses that we have in our departmental compulsory basket, and that is only 13. Contrast this with this 13 with the 23. Now let's talk of electives. So we understand at our side, we understand the fact that what we teach in the departmental core is just the ABCD of civil engineering. Then if somebody wants to read the EFG, somebody would like to do something in structural engineering, somebody would like to do something in environmental engineering. So we have this concept of departmental elective courses, and we have somehow been able to create only 4 to 5 courses and slots in this departmental elective basket. Then there are some open elective baskets, which we believe should give students a little bit of leeway in terms of if they are really interested to pursue some finance, they want to pursue some data structures, whatever they want to do. So they should be able to, or they should have some flexibility in our system, in our system, to enable them to do that. And there are about 6 to 7 open elective courses here. Now, if you do the arithmetic of this, the institute core is 124 credits out of the 426 credits, which is the total. Departmental compulsory is 109, department elective is 40, open elective is 54, and so on. So all this is there. Now, these are the percentages that we have. And if we simplify this matter, the institute core plus science and options and engineering courses is 74 credits, about 40-odd%. Department compulsory is about 20-odd%. Department elective is 9, open elective is about 7 or whatever, and HS is about 11. So basically, if a student is committed to civil engineering, he says that all his open electives also he will take in civil engineering. Then also he will only take 203 credits, which is about 48% of his total requirement in civil engineering. Whereas if the student says that I'm not going to take any of these open electives in civil engineering, I'm going to do only department electives, open electives, I'll do data structures and I'll do finance or whatever I want to do, then his departmental or the professional component is only 35%. So basically, depending on what the student takes, the student graduates from Iit Kanpur having done about 1/3 to half of his total credit requirement in civil engineering. So when we talk of 4 to 40 challenge, it's not 4 to 40. Out of those 4 years, only half or 1/3 of that 4 years is being used for imparting civil engineering itself at IIT Kanpur. Now, you may go back to your own grade cards if you still have them. I mean, some of you may not even have them. Please try to see how many civil engineering courses that you do. Okay, so that will give you an idea of, okay, this is what was the perspective in which this discussion was held. Now, if we do all this, then we come to the real civil engineering. That is the practice side of it. There are masons, barbenders, plumbers, electricians, welding. Again, there is a spelling mistake. I mean, it's bad. I don't think it should. It's a good idea to have coming at this level. For there to be spelling mistakes, my apologies for it the second time around. Maybe if some of them have crept in, I don't know, but this is the second spelling mistake that I have seen myself. Then there are these issues like mechanization, contracts, materials, finance. See, don't think that finance is not part of a civil engineering. I mean, all this PPP kind of discussion that's happening, all these so-called franchisees who are coming in to do certain things, who else will know the matter better than civil engineers? Quality and safety in construction. This is something that is so critical. I mean, as a civil engineer, I kind of feel very, very bad when I read an accident at a construction site. So, I mean, I don't know how many of you are from North India. Probably there was about a year and a half ago, or maybe 2 years ago, they were trying to erect a girder in Banaras, and that girder collapsed. It fell. There were vehicles moving on the road, and the girder fell on those vehicles. Certain number of people unfortunately died. Now, it is absolutely callous. I don't know. Somebody will say, well, I had asked for permission for the vehicles to be stopped. Somebody didn't give me permission for the vehicles to stop the vehicles. And then they were forced me to go ahead with the construction operation without observing safety precautions. All that is English to me. As professionals, we must understand that this kind of passing the buck, that I asked you for permission, you did not give me the permission, therefore this happened. This is an internal story within engineers, within civil engineers, within different people in the game. I mean, it's like wicket keepers telling the first slip guy, "Tumne catch chhod diya." He says, "You left, drop the catch." And finally, the team has lost. The team, that catch should have been taken, it was not taken. That responsibility we have to take. Life cycle cost, environmental cost, labor laws, construction labor, major issue these days. All this business of labor laws. Where do you think all this will go? We need to understand this as civil engineers. These are almost conspicuous by their absence, even as electives to civil engineers. Somebody has to teach these things, right? You have to learn. I mean, you can say that, well, I don't need teachers. We learn ourselves. That's fine. That is the continuing education that we're talking about. So now, college education in general. Now, let's come to the conclusions on this part of the discussion, which will be about, and I'll have another 10 minutes to talk to you. College education is general in nature. It does not address specific issues. Plug and play engineers will simply not be available to you. Now, the employers can blame the colleges for the bookish education. They can keep blaming us. We'll smile and move off. Or they can develop a formal, well-defined continuing education system suiting their specific needs. This is the crux of the matter. If employers come up with a formal, well-defined continuing education system, that is what is continuing education that we are talking about. But the questions now will be, who designs the contents of these programs? Obviously, the employers. I mean, if I'm an employer and I have a cement plant, I'm an employer, I'm running a RMC plant, I'm an employer, I have a construction, steel erection business. So I decide the content of the program. I decide that these things you do not know. Let's try to find out who can teach you these things. I can teach you myself, or I can find somebody else. How is this content to be delivered? Now, is there an evaluation or assessment of the participants? See, the education side, when we talk of BTech or what in education, evaluation is a necessary evil. We are forced to give an A grade and a B grade and a C grade. say that this has a higher CGPA, this has a lower CGPA, and so on. That's part of the education process. In continuing education, it's not required. I mean, I don't see it's required. If a cement company decides that these are the 10 engineers who need to be taught something, go ahead. I mean, they don't have, I don't want to be in the evaluation system of 10 engineers. That's where the matter ends. So long as they've learned, I don't really care whether one person has learned one bit more or another bit less. So that is something which has to be decided as a policy. I mean, I can help decide, but then it's the employer's call. Should there be a degree or a certificate associated with it? What should be the output of that? How do you incentivize? So these are the kind of questions which we need to answer. What is the recognition for completing the program from the employee's perspective? Then we have this whole idea of registered engineers, licensing the engineering profession. We have these kind of systems of registered engineers or licensed engineers. Those of you who are working from in abroad or who had experience working abroad, they have professional engineers or licensed engineers, and they need to renew their licenses. They need to say that, okay, this license is valid. In the US, for example, they'll say that the professional engineer's license is valid in the state of Oklahoma, or is valid in the state of Texas, and is not valid in another state, and so on. So, and that has a validity. So you have to keep revising your, renewing your license. It's not absolutely like a driving license. You have a license to drive a car, you don't have a license to drive a bus. The license has come up for a validity for 5 years. After that, you have a process by which it is renewed. The companies and professional fraternity have to answer these questions. Surely academic institutions can be a part of the lot of this business. I mean, we know these things, but we cannot fit them into our undergraduate curriculum. The exact contents can be agreed upon. There can be a lot of people. There are a lot of people. See, when I say that people should teach, it's not necessary that I will teach. And I don't know enough to teach a professional engineer. Somebody who comes from site, that person probably knows more about construction using concrete or construction using steel than I would know. But I can help him understand which he has some doubts about. With the online business, yes, the material can be recorded and delivered, made available so that the guy can read it on his own. Now, what are examples that I can throw at you? A design consultant wants their engineers to be trained in the provisions of earthquake-resistant design of finite element methods. Well-defined problem. Somebody wants to design a 20-hour module on earthquake-resistant design. That's a design consultant's requirement. A cement company wants their civil engineering employees to know more about heat transfer, to better understand the cement manufacturing process. Heat transfer is not something which is taught to civil engineers in a big way, but our mechanical engineering department has that, all those facilities. You send your civil engineers somewhere, put them through this heat transfer kind of course, heat and mass transfer kind of course, 20 hours, 25 hours, spread over a week. They'll know enough about heat and mass transfer to be able to understand the cement manufacturing process better. A construction company wants its engineers to know more about the properties of fresh concrete, especially in the context of using ready-mix concrete. Now, those of you who are in the cement business or construction using concrete, you will understand this thing very clearly, because the kind of discussion that we have in the classrooms is very different. It's very, very fundamental, and you need to go there. Now, the point is that evaluation we've already covered. So now, is having a BTech degree a license enough for all time? That is the question that you guys have to answer for yourselves as employees, as employers. Can there be a series of professional certification courses operated by professional bodies? You pick up ICI, you pick up anybody, and they can say that, well, that's what it is. We will have some certification programs that we take, yes, but then there's a professional body which says that I'll qualify you as a practicing engineer with knowledge in concrete or whatever it is. We can have licensing systems in the area of design, construction, inspection. All these are very, very specialized things. And larger construction companies can surely say that, okay, we have 100 people, all of them are qualified in construction, some of them are qualified in design also, some of them are qualified in inspection also. So these are the kind of thoughts that come to my mind. Education in internet era, one has to be very careful. There's a lot of information available. You have to decide the quality, choose your own courses, choose your own bouquet, and we can allow credits for these completed. So you can ask your employees to say that, okay, these are the 10 courses out of which at your leisure you please complete 4 or 5 of them. You can use them for manpower development programs. Now the problem will be with laboratory work and evaluation. We can work towards evaluation business. Quality control in education process. Now, whether you have learned, somebody comes and tells you that I've completed this course, you really believe in, take it at its face value. Those are things you have to answer. Now, coming to the conclusions, I think I'm almost running out of time. I might have already overstepped my time.
The time is available, not an issue.
Okay, fine. So I'll go a little slow on the concluding remarks and kind of stick to the normal pace at which I was. See, the college curriculum tries to have a balance between science, rationality, practice, and the whole works. And only limited knowledge can be imparted, especially in the context of practice. Colleges, of course, they need to develop and nurture and develop their faculty. I mean, we need to do a little. See, even in colleges, we often say that a PhD is required to enter. Now, having a PhD doesn't mean that you know everything. You know, in fact, a PhD is a very narrow band, very highly specialized business. So you have to teach yourself, and we try to do that. A lot of you may not believe it, but we do try to study, keep ourselves abreast of what's happening in the world, and that's what probably differentiates one college from another, and so on. Employers need to come forward and design their own orientation programs as part of bridging the gap. So it's like saying that, okay, there's an island here called academia, there's an island here called the practicing business, and there is no bridge between the two. So who has to build the bridge? I mean, we cannot build those bridges because we have to build bridges to all these different islands. I mean, designers, contractors, and so on and so forth. So each of these people can come up with those bridges. The industry needs to go up and take more professional responsibility for its education and training of its employees. And that needs to become part of the corporate thought process. Okay, because very often when we run some of these programs, see, it's part of our mandate to run continuing education programs for the industry. And very often when we run the programs and we send a brochure out to an industry, they say that we cannot spare people because I don't think we have, because they are busy. Now, being busy is all right, but you have to understand that your manpower needs to be trained. Okay, so this is where I'm closing. These are take-home questions. The answers need not be submitted, but they need to be worked out for yourself. How does a skill upgradation fit with the manpower development plans of your company? Okay, so this skill upgradation is an open-ended thing. You decide for yourself what is a skill upgradation for your particular environment, and decide as part of the manpower development plans what percentage or absolute number of time is an employee expected to book towards self-study, and how is such time monitored? See, I mean, because I've worked with some of these companies, I've spent about 10 years working for all these places, so I know that we used to fill timesheets. That, okay, every hour we are supposed to book. I mean, every hour if I'm working for something, I'll book it for project 1 or project 2 or project 3, or book it for self-study, going and attending a meeting somewhere else. So now, what is in your company? What is the amount of time that an employee is expected? I mean, do you have a policy which says that at least 5%, 2%, 10%, whatever that number is you can book towards self-study? What is the annual budgetary provision for manpower development, and is it effectively utilized? These are the questions which I am leaving you with, because these are central to this whole business of foreign policy. In that 40 years of education, I mean, now education is different for different people. I mean, when you say 40, people who come in at 25, they need an orientation program. Once they get towards 30, 35, with the first level of promotions and so on, they need a different skill set. At 45, they need different skill set. and how that's how it moves. So that is how we have to do a planning, formal education in terms of training, so that your employees are well versed with the latest developments. In a company where I used to work, they used what they said. My boss's boss, somebody very senior to me at that time when I was much younger, that guy said that, well, you guys have to learn. We are investing in you, and you have to carry the company forward. Because unless you learn, because what you learned in colleges, we are willing to write off. We don't care what you learned in colleges. You should learn the way we work. You should learn what is important to us. What is our value system? What are the things that we encourage people to have, all of you to have, some of you to have, and so on. So if educating the juniors is also a part of a senior in a company. So if the educating the junior, obviously that manpower booking can happen only if you are an educator, an identified educator in your company. How many such people do you have? What is the kind of education they are imparting formally? See, it's not enough to just go on job all the time. See, on job has its own limitations. Okay, so I think I've taken all the time that I needed to do. Thank you so much. I enjoyed talking to you a lot, and I hope that you I don't know whether you enjoyed the talk, but at least there are some questions which you're taking back. And if you are able to apply your mind and kind of think about those questions, I think the purpose of this talk would have been served. Thank you so much. And thank you, Ramco, for giving me this opportunity to talk to you and talk to all.
Very nice, sir. Because you have taken it, you have tried to bring a coordination between what is being taught at the college and what can be done, rather than having a blame game. I think that is a better option, better approach to be followed. Because you have looked at the curriculum part of it and you have said that this is what is being taught. Now, if you want something customized teaching that needs to be done, that also is possible. I mean, it's not that it is not possible, it's possible, but then we need to take a proactive step for that. I think that's a very good thing. There are a couple of questions also which have come about. Although you have left us with questions, but there are participants who have asked some questions. So
oh, yes, absolutely. I mean, in this business, I should not be shy of questions. What are the questions?
I think one question is how we can have this practical experience in civil engineering that you were talking about, like say, for example, plumbing, masonry work and all, which is relevant. How can we have this practical experience while doing the graduation? Is it possible, or is there a better approach for it that you recommend?
I don't think it is possible. See, for the simple reason that none of our teachers, including myself, I'm not a mason, so I cannot teach you masonry. I'm not a barbender, so I cannot teach you barbending. Okay, so the only place to learn these skills will be to go to a site. So, in fact, in the good old days, what was it called? It used to be called summer training or something like that.
Yes.
Summer training was a part of education that you were expected to, you means the students were expected to spend about 6 to 8 weeks at a site trying to understand a few things, whatever it is. Now, different colleges have adopted different systems in the modern era, and IIT Kanpur has done away with this summer training concept. We don't require it as an educational requirement. We leave it to the students. If they want to go, they go, and so on. So it is iffy. So there is, on the face of it, my answer immediately would be a very difficult situation to do unless you are motivated and learn it yourself.
Another question is, in medical examination, there won't be any choice in questions to be answered. The same can be implemented in our career if possible, which a graduate will not leave any topic in academics.
Well, it's a difficult question. I think we have some of these things are difficult to understand just from the question which is asked. But my answer or comment on that really would be that, see, in India, by and large, having seen a little bit of different educational systems, we have an extremely straight-jacketed program we don't allow flexibility. In most of our engineering colleges, we don't, I mean, at least, I mean, I would think IIT Kanpur is probably more flexible than others, with allowing about 4 or 5 department electives and 6 to 7 open electives. That means that you have at least total about 10 to 11 electives, and you have only 13 compulsory courses. So now we allow the student a lot more freedom to pursue his or her interests. But in a lot of other engineering colleges, it's a lot more straitjacketed that, okay, this is the curriculum, only very few electives, and so on. So it's difficult to do that, and we need to be a little more open now in our education system. Yeah.
I think one of the important points that you touched upon was that practice is what is important. And I think, even if you take say, for example, swimming itself, we can learn a lot of books on swimming. But unless you don't get into water and try to experiment with it, I think probably you cannot be a good swimmer.
My only request, see, I mean, in fact, let me share with you. I sometimes hesitate to send my students to a site for this reason that the person who will teach them there, if he teaches them what is going on at site, that's fine. But if he prefixes it with saying that what you have learned is useless, it is never going to be used, this is what we do at site. That is the most damaging thing, because that poor student, he will tend to believe that guy more than me. Because he will say, okay, these guys is only teaching in the classroom, doesn't know anything about the field, which is true. And that will be wrong education. See, that is where in medical education, even in the hospital, a lot of teaching is being done by the doctors and not compounders. Right? So there are these skilled professionals, even in medicine, people like compounders, pharmacologists. So they have their own place. I'm not denying that at all. So you have to understand that, respect the fact that there are masons, there are barbenders, which you are not. So that's where it is. Okay.
So thank you so much, sir. That was a very interesting talk. And those of you who have missed the talk, you can also see the Facebook Live, which is there on our thing. And we would also be uploading this on YouTube so that you can again listen to the talk and probably apply your mind and see what can be done. Because this is the need of the hour, to see how we can make more engineering graduates employable. And I think the collaboration between companies and educational institutions will definitely go a long way in making this happen. Because both theory and practice are required to make a civil engineer more efficient and more productive. I think with those words, let me again thank Dr. Mishra Saab for having given his time and for sharing his experiences and his thought process in a very succinct PowerPoint presentation, and he has also shared his experience. Thank you so much for that, sir.
Thank you so much.
It was nice having you here, and we will again meet tomorrow at 11 a.m. And we would be talking about our speaker acting concrete tomorrow at 11 a.m. So thank you, and have a be safe all practice all precautionary measures during this era of pandemic, and all the best wishes. Thank you so much, sir.
Thank you.